Hello and welcome to my next video. In this video, I'll be explaining about gravity in depth. In the last video, we saw about two formulas and how to derive one of them. In this video, I'll be talking about gravity in depth, that is including the topics such as acceleration due to gravity and the use of gravity in the rotation of moons and planets. First, what is acceleration due to gravity? Now, there's a boy and he's having a ball with him. If he throws the ball upwards, then the ball will travel some distance in the sky. If after some point the ball will begin to drop, till that point it will be accelerating upwards. What is the thing that makes the ball come downwards? It is gravity. So the ball comes downwards with the force of gravity. As in the last video, I discussed that the force of gravity, that is G, is equal to 9.8 meters per second square, meaning that it is a force that the gravity will be exerting on an object. So this ball will be experiencing a force of 9.8 meters per second square. So then this ball will be experiencing a force of 9.8 meters per second square when it is dropping down again. This is the force that the ball will be coming down, meaning that it will occur a speed of every second it will have a speed of 9.8 meters. It will be increasing till it reaches the ground. So this is how the ball, and when the ball is thrown up, it will have a constant speed and it will decrease if there isn't any further acceleration from the starting point. So now let's assume that this is the Sun, this is Mercury, Venus and Earth. These are three planets which is revolving near Sun. And how does this revolution occur and the rotation occurs? Let me make one thing clear to you. Gravity is like a big magnet. It's like a magnet. It attracts things together. Meaning that all objects will possess gravity between them. Mercury will possess an attractional force towards Sun, and Sun will possess an attractional force towards Mercury, and it will happen to all other objects revolving around Sun and all other planets on the moons revolving around their own planets. So gravity is present everywhere. Gravity makes space bend and time to occur. So now, what about the other planets in the solar system which are very far away? Then the force upon the gravity from the Sun will be so small, meaning that they will be having a very large orbit and they will revolve slower. So why do these objects near the Sun revolve faster? As I told you before, less the distance, more the gravity. If the distance is less, then the gravity, the attraction of the force of the gravity will be more. So what will happen to these objects? As you can see, if you bring two magnets very close together, they start to come closer together very fastly. And as you take the magnets away from each other, the force of attraction will be less. The same case is acting on here. As you can see, the nearest planet near the Sun is Mercury. It travels faster than any other planets. Then the next nearest is Venus, and the next is Earth, and so on. So the last planet will be forcing very less force of gravity from the Sun. Now, let us talk about the case of the Earth and the Moon. Earth is bigger and will have more gravity than the Moon, as the mass of the Moon is smaller than of the Earth. And the gravitational force of the Moon is 1/6 less than the Earth's gravitational force, meaning that the gravitation of the Earth force is so much stronger that it has a capability of pulling Moon. But unfortunately, the Moon is moving away from Earth at 2 centimeters per year. Now think of what would happen to the moon if the Earth's gravitational field and the mass was more stronger than now it is. Then the Earth will engulf the moon inside itself and make a catastrophic damage when life on Earth will not survive. But that's very unlikely to happen because now the mass of the Earth is prominent for the mass of the moon and the moon is moving away. Now I will be discussing about gravity in rocket propulsion. What does gravity in rocket propulsion means? The change in gravity from a rocket which is moving boosting forward into the Earth's upper atmosphere. So how does the gravity affect in the movement of rockets? So here is a simple rocket. This rocket is going upwards. Let's say it is traveling upwards. So what happens? Let's say it's propelling forward, meaning that it will go up into the atmosphere. First, at the ground level, the gravity will be acting at its most. And this is a point to remember. The more deeper you go or you get down into Earth and you get lesser than the height, the gravitational force will increase. But at the same time, if you go upwards as escape from the Earth, the gravitational force will decrease. As I told you that more the distance, less the gravity. So now what will happen? At some states, the gravitational force might be around 100 meters per second square acting on it. And after a stage, when it crosses a stage of the atmosphere, it will decrease to 50. And so on, it will keep on decreasing as the height of the rocket increases. That's why an object propels when it has propulsion against the gravitational force. So after a time of propulsion, the velocity will little increase because of the absence of gravity. And if you propel in a vacuum where there is no gravity force or very less gravity force, then the propulsion will be very high. The velocity of the propulsion will be very high. I hope you all enjoyed the video and thanks for watching.